students, welcome back to class. Here are the objectives of our lesson today. 1. At the end of today's lesson, all the students should be able to state the ions discharged at anode and at cathode when inert electrodes are used in the electrolysis of copper 2 tetraoxosulfate 6. The second objective is that all of you at the end of the day should be able to state the ions discharged at anode and at cathode when copper electrodes are used for the electrolysis of copper 2 tetraoxosulfate 6. The third objective is that at the end of this lesson, you all should be able to write the equation for the reaction at cathode and at anode when inert or copper electrodes are used for the electrolysis of copper 2 tetraoxosulfate 6. And lastly, at the end of today's lesson, you all should be able to write the overall equation for the reaction at cathode and at anode when inert or copper electrodes are used for the electrolysis of copper 2 tetraoxosulfate 6. Let's begin with the electrolysis of copper 2 tetraoxosulfate 6 solution using inert electrodes. Inert electrode could be carbon or platinum electrode. A solution of copper 2 tetraoxosulfate 6 will contain ions from water. And what are those ions from water? We have OH minus hydroxide ion, and we have H plus hydrogen ion. And ions from copper 2 tetraoxosulfate 6. And what are those ions from copper 2 tetraoxosulfate 6? We have copper 2 ion and we have tetraoxosulfate 6 ion. So the two cations that are present here, which is hydrogen ion and copper 2 ion, we migrate to cathode, but only one of them, of course, will be discharged, and the one that will be discharged here is going to be copper 2 ion because it is lower in the electrochemical series. You can see the position here. It is lower in the electrochemical series than hydrogen ion. Inferably, it means that copper 2 ion is less electropositive compared to hydrogen ion. Therefore, copper 2 ion will be discharged at the cathode because of its position in the electrochemical series. And at the same time, hydroxide ion and tetraoxosulfate 6 ion, the two of them will migrate to the anode, but hydroxide ion will be the one that will be discharged. What happened? This is tetraoxosulfate 6 ion and this is hydroxide ion. So tetraoxosulfate 6 ion is more electronegative, while hydroxide ion is less electronegative. Therefore, hydroxide ion will be the one that will be discharged at the anode. Let's look at the reaction process. We can see these are the ions produced by CuSO4, that's copper 2 tetraoxosulfate 6. This is the cation from CuSO4, and this is the anion from CuSO4. These are the ions produced by H2O, CH plus, the cation, and OH minus, the anion. And by the way of concentration, we can see the concentration of CuSO4 is higher than concentration of the ions produced by H2O. And by position, Cu2 plus is just below H plus in the electrochemical series, while OH minus is also below SO4 2 minus in the electrochemical series. So if you look at the right hand side of the slide, you see the diagram. You can see the ions in yellow color. This is SO4 2 minus and this OH minus. The two of them are the anions and they migrate towards the positive anode, positive electrode, which is the anode here, while the positive ions, that is Cu2 plus and H plus, migrate towards the negative cathode, which is the negative electrode, which is the cathode here. This is how the ions migrate towards the respective electrodes. So this is the reaction at anode and at cathode. Hydroxide ion is the one that is discharged at the anode because of its position. So the hydroxide ion will lose one electron to form a neutral OH group, and because OH minus is losing electron here, loss of electron is a reaction that we called oxidation reaction. So at the end of the day, what happened? There is nothing like OH in chemistry. You don't write any chemical equation and you write OH. There is nothing like OH. It's either you have OH minus or you have H2O or you have H2O2. So what will happen is these two neutral, this OH group, which is a neutral OH group, the two will pair up together and form a molecule of water and oxygen. At the same time, oxygen is diatomic in nature. You will never see in any chemical equation in chemistry where oxygen is represented as just ordinary O. It must be O2 because it's diatomic. Therefore, two neutral oxygen atoms will pair up together to form oxygen gas. So this is oxygen gas. So what we are saying is that in the electrolysis of copper 2 tetrahydroxide using platinum or carbon electrodes, hydroxide ion is discharged at the anode. So a molecule of water and oxygen gas are the product formed. But at the anode, at the cathode, copper 2 ion is discharged, and this copper 2 ion, because is a divalent metal, it will gain 2 electrons and then become neutral. So it will produce a metallic copper, and because it gains 2 electrons, gaining of electron is a reaction that we call reduction reaction. So what are we saying? At cathode, reduction reaction takes place, electrons are gained. At anode, oxidation reaction takes place, electron is lost. This is the overall equation. We have the anodic half reaction and we have the cathodic half reaction. Cathodic half reaction is the reaction at cathode, anodic half reaction is the reaction at anode. Hydroxide ion is discharged and it loses 1 electron to form a molecule of water and oxygen gas at the anode. At the cathode, copper 2 ion is discharged. It gains 2 electrons and produces what? Metallic copper. So what happened? We discovered that the number of oxygen atoms at the reactant is not equal to the number of oxygen atoms at the product. So what you need to do is to balance this equation. So if I put 2 here, I will have 2 oxygen, but I have 3 here. So, but I will have 2 hydrogen, 2 hydrogen. So hydrogen will be balanced. Oxygen is not balanced. So if I put 3 here, I have 3 oxygen, 3 oxygen. Oxygen is balanced, but I have 3 hydrogen, 2 hydrogen. So hydrogen is not balanced. So what do? Let me put 4. So if I put 4 here, I have 4 OH minus, and I have 4 hydrogen from there, 4 oxygen. So if I just leave it this way, that means I have 2 hydrogen, 3 oxygen, which is already 4 here. So what I need to do is to put 2 in front of H2O. So I have 2 H2O. So this 2 is meant for hydrogen and oxygen. So I have 4 hydrogen, balance, 4 oxygen, 4 oxygen, 2 here, 2 here, balance. 1 hydroxide ion loses 1 electron, 4 will lose 4 electrons. This equation is perfect. So the number of electron loss and the number of electron gain must be the same, and that is why I need to multiply everything here by 2 to get what? 2Cu2 plus, 4E minus, and 2Cu. 2 copper, 2 copper. So the number of electron gain is 4, number of electron loss is 4. The two of them cancels each other. So what will then be the overall equation? Bring together the reactants at the cathode and at anode. Bring together the product at anode and the product at cathode, and that will give us what? 2Cu2 plus, that is the reactant at anode, cathode, and 4OH minus, the reaction at anode, and then The product at cathode is 2Cu, and that's what I have here. The product at anode are water and oxygen gas, and that is what I have here. So this is then the overall chemical reaction of what happened in the electrolysis of copper 2 tetraoxosulfate 6 using what? Carbon or platinum electrode. Let's proceed to electrolysis of copper 2 tetraoxosulfate 6 solution using copper electrodes. This electrolysis is different from the former because here copper anode and copper cathode are used as electrodes. So copper 2 tetraoxosulfate 6 solution is the electrolyte and copper are the electrodes. So copper electrodes are immersed in their aqueous solution, and after some times what happened is the anode begins to dissolve in this solution, and as it dissolves is forming layer on the cathode. So copper anode is dissolving and is coming to the cathode to form layers on it. So as the copper dissolves here, it forms layers on the cathode here. So at the end of the day, in this electrolysis, copper is discharged at the cathode, copper is discharged at the anode. Here is the reaction at anode and at cathode in the electrolysis of copper 2 tetraoxosulfate 6 solution using copper electrodes. So both SO42- and OH- migrate to the anode, but the two of them are too stable to be discharged because of the presence of copper in that particular electrolysis. Copper 2 tetraoxosulfate 6 solution is electrolyte. We have copper anode, copper cathode as the electrodes. So the presence of copper in this electrolysis renders every other ions in this electrolysis to be too stable to be discharged, and that is what happened at the anode. Copper anode dissolves in this particular electrolysis, and because it dissolves, it is oxidized to discharge copper 2 ion. So both SO42- and OH- becomes too stable. None of them is discharged, but instead copper 2 ion is oxidized. So copper is oxidized to copper 2 ion. Copper anode dissolves, and when it dissolves, it is oxidized to form copper 2 ion. Loss of electron is oxidation, so it is oxidized to form copper 2 ion. And what happened at the cathode? Cu2 plus H plus migrate to the cathode, and the two of them have to compete for discharge, of course, but copper is lower in the electrochemical series compared to hydrogen. So because of its position in the electrochemical series, copper is discharged. So copper is discharged, it gains 2 electrons to form a metallic copper, and that is reduction. So at cathode reduction reaction, copper gains 2 electrons to form a metallic copper. At anode, copper anode is dissolved, it oxidizes to form copper 2 ion, and that is oxidation reaction. Today in our lesson, we have learned about the ions discharged at anode and at cathode when inert electrodes are used for the electrolysis of copper 2 tetraoxosulfate 6. Also, we have learned about the ions discharged at anode and at cathode when copper electrodes are used in the electrolysis of copper 2 tetraoxosulfate 6 solution. We have also learned about how to write the equation for the reaction at cathode and at anode when inert or copper electrodes are used for the electrolysis of copper 2 tetraoxosulfate 6. And lastly, we have also learned about how to write the overall equation for the reaction at cathode and at anode when inert or copper electrodes are used. This is how far we can go today, and here is my email address. If you have any comment or any question, you can send me a mail, and my name remains Ibukunolu Ademola. Bye for now.